Given the function fx equal to x minus 3 over x minus 1 times x plus 3. Find question A, the domain of f. Question B, the vertical and horizontal asymptotes. This function is a rational function, so the denominator is not equal to 0. So we have here x minus 1 times x plus 3 is not equal to 0. So x is not equal to 1 and x is not equal to negative 3. So this means the domain is all the value except x1 and x negative 3. So we are going to write in this way. Start with negative infinity to negative 3. We put round bracket here because not included. Union negative 3 to 1. Union 1 to infinity. Next, let us find the vertical asymptote. So we are going to take the function on denominator and we put here equal to 0. We have x minus 1 times x plus 3 equals 0. So here the x value is 1 and negative 3. Now we are going to use the limits to show that the vertical asymptote are x equal to 1 and x equal to negative 3. We have to show for both sides. Means we have to find the left hand limit and also the right hand limits. So at x equal to 1, we are going to find limits of this function as x approach to 1 from left, and also limit of this function as x approach to 1 from right side. Let us find by using the direct substitution. We are going to substitute x with 1 into the function. So we have 1 minus 3 over 1 minus 1, 1 plus 3. So this is equal to negative 2 over 0. Another one, we have the same thing. Which is equal to negative 2 over 0. Now, we are going to substitute the values that close to 1 from both sides. So here is a number line. I put here 1. So when x is approaching 1 from right side, we are going to substitute the nearest value, which is 1.1. And when x is approaching 1 from left side, we are going to substitute 0.9. Now, for the first one, approaching 1 from the left, we are going to replace x with 0.9. We will replace it over here. So we get 0.9 minus 1, 0.9 plus 3. We get negative 0.39. So this is a negative value. So we are going to put here 0 with negative sign. Another one, when approaching 1 from the right side, let us replace x with 1.1. Replace it over here, the denominator part. So we have 1.1 minus 1 and 1.1 plus 1. So here we get 0.9 to 1. This value is positive value, so we put here the positive sign. We have here negative value, and this is also negative. So when negative times with negative, we get positive infinity. Infinity because when a value divided by very small value, we will get a very large value. Another one, here is negative value, and this is positive value. So negative times positive, we get negative infinity. Now let's continue find the limits for the values x equal to -3. Same like the previous one, we are going to find the limit for both sides. So we have the left hand limits. This is when x is approaching to -3 from left side. Another one, we have the right hand limits. This is when x is approaching -3 from right side. Now, let us find by using the direct substitution. We are going to substitute x with -3 into the function. So we get here -6 over 0 and this one is the same, -6 over 0. Now we are going to substitute values that close to -3 from both sides. Here is a number line, so I put here -3. Now let us find the value that close to -3 from left side. So we can choose -3.1. And when approaching to -3 from right side, so over here the nearest value can be -2.9. So when x is approaching to -3 from left side, we are going to replace x with -3.1. We replace it here, the denominator part. So we have -3.1 minus 1 times -3.1 plus 3. So this is equal to 0.41. This is positive value. So we are going to put here positive sign. Now, when x is approaching to -3 from right side, we are going to replace x with -2.9. We are going to replace it here. -2.9 minus 1, -2.9 plus 3. So this is equal to -0.39. This value is negative value. So we are going to put negative sign here. So we have negative times positive. So this gives us negative infinity. And here we have negative times negative. So it's equal to positive infinity. So based on these limits, we can make a conclusion. So the vertical asymptote are x equal to 1 and x equal to -3. Next, let's find horizontal asymptote. We are going to find limits when x is approaching to positive and also negative infinity. This one we call it as infinite limits. Now, let us start with direct substitution. We are going to substitute x with infinity into the function. So we get infinity over infinity. This is indeterminate form. So to solve this, we are going to divide both numerator and denominator by the highest power of x in the denominator. First, let us expand the denominator. So we get x squared plus 2x minus 3. So the highest power on the denominator would be x squared. Now, we are going to divide each term by x squared. Next, let us simplify the function. We have 1 over x minus 3 over x squared divided by 1 plus 2 over x minus 3 over x squared. We are going to replace x with infinity into the function. So we have 1 over infinity, we get 0. 3 over infinity is 0. 1 plus 2 over infinity is 0. And 3 over infinity also 0. So the values that we get is 0. Now we are going to find limits as x approaches to negative infinity for the function given. So first, let us substitute x with negative infinity into the function. So we get infinity over infinity, which is indeterminate form. Now, again, we are going to divide both numerator and denominator by the highest power of x in the denominator. Now let us expand the denominator. We have x squared plus 2x minus 3. Now the highest power of x in the denominator would be x squared. Let us simplify the function. We have 1 over x minus 3 over x squared divided by 1 plus 2 over x minus 3 over x squared. Next, we are going to replace x with negative infinity. So 1 over infinity would be 0. 3 over infinity is 0. 1 plus 2 over infinity is 0. 3 over infinity is 0. So the answer is 0. So based on these two limits, the answer that we get is equal to 0. Now, you can make a conclusion, say that the horizontal asymptote is y equal to 0. Well, that's it. Thanks for watching.